This is Kenneth Wong, Senior Editor for DE 24/7. Welcome. This is part of our December 2021 Industry Leadership Profiles podcast series. Simulation software vendors have been talking about democratizing simulation, making it widely accessible to a wide range of people for a long time. And one way to do that is to make use of the ubiquitous cloud architecture. Today, on that subject, we talk to David, CEO of SimScale. David, welcome. Would you mind giving us some background information about who you are?
Hi, Kenneth. It's a pleasure to be here. Thanks a lot for having me, and also a warm welcome to the audience. And thanks a lot for carving out time to listen. Sure, a bit of info about myself. I have a background in applied math and mechanical engineering. I've been involved ever since in scientific computing, wrote my diploma thesis on multi-phase flow methods, in fact. And then 9 years ago, we founded SimScale with the belief that there's a lot of untapped innovation in making simulation more accessible beyond, the late stage design validation in large organizations where it's primarily used, even up until today in most organizations. And so ever since, we executed on that vision. And of course, in the early days, I wrote a lot of code myself still. Now with SimScale growing, we've just passed 100 team members. I guess my day-to-day activities has slightly changed. But at the core, a lot stayed the same. We're still in the business of helping customers innovate faster by making simulation more accessible.
Okay, let's talk about this culture shift that you are trying to facilitate here. Traditionally, FEA is done with software that is installed on a powerful workstation, and if necessary, augmented with additional computing powers from a server or a data center. Do you think the engineering community is willing to adopt and use cloud-hosted software now?
I think there's a short and long answer to this. The short answer is yes. There's many engineering organizations that are ready to or have already adopted cloud-based simulation. SimScale alone, is indicative of that. We've been fortunate enough to onboard hundreds of thousands of users, work with thousands of engineering organizations, running millions of simulation jobs in production over the past years. And so, and growing fast, and that is indicative of that cloud adoption for simulation workflows is real, right? And not just a dream for the future. And we're not the only vendor or company working in that space, right? There's more, and they see adoption. And so as such, this is happening. So that's a fact. Now, the longer answer, or the longer part to this answer, is certainly that a broad adoption of the cloud for simulation workflows doesn't happen overnight, right? That this is a process that has been steady over the past years, and that will still take years from here on out. And the reason is that this is not a point solution or a small productivity tool in a marketing and sales tool stack. It's a critical piece of software, a critical part of a hardware engineering process, and that takes time to change. Still, we believe that by the end, at the end of it, the adoption of cloud for simulation is almost inevitable, because there's macroeconomic or high-level trends that are here to stay, and where the cloud can help to cope with them. And that starts with the ever-increasing pressure of shipping better products faster at lower cost, right? That isn't going anywhere. That is here to stay. And it will require engineering organizations to find better product designs quicker. And for that, you need to simulate early in the design process, broader in the organization. You need, design processes will have to change, and cloud-based simulation solutions can help here. But beyond that, it's not just this, ever-increasing pressure. It's also the latest with COVID. We've seen that engineering organizations are more dispersed, are more remote, need to be more agile. Supply chains can be disrupted, and for that, we're in a new reality of teams forming quickly, disassembling quicker, remote work. And again, a cloud-based simulation workflow can help here as well. I could go on, right? We could talk about the advent of the digital twin, where cloud-based simulation technology will play, or can play, an important role, and more about those facts. So, what I'm trying to say is that there's macroeconomic trends in hardware engineering that we believe will drive the adoption of cloud simulation faster and faster over the next years.
David, since you talk about this as a process change, really, would I be correct to assume that it will take longer for established large enterprises like aerospace and automotive giants to adopt software in the cloud, whereas startups are more willing and able to um, very quickly adopt something like that? Is that the correct way to look at it?
I think by gross and large, yes. I think I don't think it's 100% correlated with the size of the organization, but I think by gross and large, yeah, the like changing existing sort of incumbent workflows, calibrated, validated simulation models is certainly taking longer than an organization that sets up, a fresh design software stack or engineering software stack for sure. Yeah.
What do you say to people who usually bring up security concerns? There may also be cultural resistance because people are just used to working on the workstation and they feel more secure, or there may also be legitimate concerns about some industries where the regulation requires that they keep data a certain way and not in the public cloud.
Yeah, so I think there's these different facets to it that you already touched on. For sure, there's a compliance factor, right? And if a cloud-based solution isn't compliant with a given industry standard, then of course that's a legitimate concern, right? That rules that cloud-based solution out for that specific compliance. Now, you are right that more often than not, it's more an emotional aspect because outside of compliance, right, if an organization just has historically preferred to have on-site hardware and locally installed software, there's oftentimes, yeah, just an attachment to this way of doing things. And if you look at it in a sober way, a SaaS service provider or a cloud service provider oftentimes has full teams that are only dedicated to IT security. That technically you might be better off with the security given by your full-time team that takes care of IT security at your cloud service provider, other than doing that yourself, depending on the size of the organization. So I think it's this, the compliance, technical, and emotional aspects that need to be separated. By the end of it all, I think it's the same as we've seen SaaS and cloud adoption in other industries, right? As those offerings mature, as more and more compliance as more and more standards are being complied to by those SaaS software providers, that will accelerate adoption faster and faster. So I think in engineering software today, we're having the discussion around these security concerns that probably were in the CRM world or the ERP world maybe 10 years ago, right? And so eventually, we believe also that will be overcome.
Let's talk about what people get when they signed up for SimScale, because it's a subscription model, so it's a little bit different from a software that one would install. But what are the different type of scenarios that they'll be able to simulate, and what kind of solvers are accessible to them?
So at SimScale, let me start first by saying SimScale is a completely cloud-based platform, so cloud native. That means we're rapidly innovating on it, rapidly expanding it, shipping, very, very often. And that's the beauty of SaaS, right? Everyone has always the latest version. All migrations are done by us, etc. So one can innovate much faster in the cloud than with a local desktop deploy. That being said, today SimScale's capabilities are primarily in structural, thermal, and flow. And so I think it's fair to say that in all of those three areas, we have a fairly broad offering. All the, I guess, analysis types you would expect from a professional simulation solution starts with, steady state and transient analysis and structural analysis, of course, linear, nonlinear mechanics, many different types of material models, assemblies and parts, etc. on the structural side of things. And then over to flow, incompressible, compressible, laminar, many different turbulent models, multi-phase, single phase, species transport, etc. And then going into heat transfer, conduction, convection, both of it coupled, right? And a conjugate heat transfer analysis, and then all the way to radiation can also be fully coupled in. And so as such, we cover, and that is also a bit of our product strategy, right? We cover a very broad range of the general purpose engineering challenges that happen across many different industries. And that's also reflective of SimScale's customer base today. So we have many customers from, architecture, automotive, consumer goods, pharmaceutical, biomedical, a lot of industrial equipment, rotating machinery, et cetera. So it's a fairly broad account base. Now, on your question with solvers, we like to say that we work backwards from the customer problem, from the applications and engineering challenges the customer has, and then we just choose whatever the best method is in the back end of SimScale. And so as such, over the years, we've been integrating several solvers, in fact. So on SimScale today, we employ multiple different methods, and that one is an implicit finite element solver, and then it goes into CFD side of things, where a traditional body-fitted finite volume solver, then a GPU-based lattice Boltzmann solver, and then just recently we integrated also another finite volume solver that has very specific capabilities with respect to automatic meshing and fast turnaround times. So you see, there's many different solvers, but we like to sort of concentrate on the customer problem and just have the method, whatever the best method might be to solve that problem, have it simply available as part of the SimScale subscription.
A lot of the people who use simulation tends to want to do what is known as design of experiment. So a wide swath of design options evaluated at the same time. So when the results come out, they can pick and choose the best, the most stable, the optimal design. In order to do that, people often say that it's been really difficult to estimate how much a particular session will cost. Do you have any tips, for example, on SimScale's model licensing structure? Will it be reasonably easy for them to estimate how much it'll cost to run such an experiment?
So I think there's, I guess, probably almost three novel aspects here when you go with this into the cloud. The first, it starts with the licensing model. Many licensing models of traditional, desktop deployed softwares have the limitation that you can only use it on so and so many cores, right, or on so and so many nodes. And so it's hardware constrained what your software allows you to do simultaneously. With SimScale's licensing model, that constraint is gone. So you can run as many simulations as you want simultaneously, right? So one SimScale subscription enables you to do that. Now, of course, the computing time that is used by any given by any given compute instance to run your simulation on, of course, this is deducted from your quota, and so there's a quota component to it. Two more things here. Very, very often is the cost of this incremental simulation, or of an incremental simulation run, is so marginal compared to the, to any other software licensing cost, and also to the engineering time you put in, that for many design studies, customers just don't even care. And when it becomes relevant, so for example, one example that I could list here is we have fairly advanced wind studies with the GPU-based lattice Boltzmann solver that are very large, hundreds of millions of cells running in GPU instances. So there, the incremental simulation, might at least, the cost of it might at least become relevant. And so in such situations, what the cloud, also a system such as SimScale, brings is the ability to predict what the runtime and what the required resources for a run before the start, to predict that already, right, and to give you an estimate of to see whether or not you're willing to invest that. And that is also because the on SimScale we're running tens of thousands of simulations a week, and so that gives us the ability to train predictive models, machine learning models that can predict just based on the uploaded geometry as well as the simulation setup that specifies the physics, the runtime and compute resources required for that simulation run. And so as such, a priori, it's possible to see how much runtime and computing costs will occur from a given run. And so oftentimes it's really if the incremental simulation run cost is really, relevant, then you could use such a predictive model to already gauge if you're willing to invest that amount of money.
Very good. David, thank you so much for going through the licensing models and the cultural changes and all the implications. I really appreciate it.
Of course.
All right, ladies and gentlemen, that is all for this episode. Until next time, I'm Kenneth Wong for DE 24/7, and we are